Hi everyone, I'm Dr. Saranya and I'm going to present a topic in computer networks which is about error reduction. So under error reduction, we are just going to discuss about the types of errors and reduction methods that can be used. So before moving into the topic in detail, first we can just discuss about the basic concepts that is needed to know about error reduction. So networks must be able to transfer data from one device to another with complete accuracy, right? That's what we all will be expecting. But when any corruptions that is happening during transmission, there must be some reliability in transferring our data. So that is what the methods that was introduced for reliable communication, which is data, that is error reduction and correction methods. So which is being implemented in data link layer or in the transport layer of OSI node. So here these are the different types of errors: single bit error, multiple error and burst errors. Let's have a small discussion about what is single bit error. When the sender and the receiver is sending the data and there is a change in only one bit of data, that is called as single bit error. Whereas burst error, when the sender and the receiver during the transmission, there is a multiple set of series of data is being changed, or it is being denoted with a high set of bit, that is more than one bit. That is what we call it as burst errors. So whereas two errors means when the data is being sent, the two errors, that is this one is being reflected as 0 and this is 0 is reflected as 1. So this is only 2 bits has been error. So that is what we call it as 2-bit errors. So there are three different forms. One is single bit, 2-bit and burst errors. So how these errors can be corrected? Using error reduction methods. So this error reduction is the basic concept of redundancy, which means adding extra bits of reducing errors at the destination. So whenever an error is getting occurred, so this error reduction method can able to uh, correct your data, what is being. Now let's know what is redundancy. So redundancy is nothing but, you can see here how the data is being redundantly checked out when it is being transmitted. So before transmission, this redundancy check will be made for better understanding how the data is being transferred in a proper manner or not. Okay, so this is what about redundancy here. So this redundancy is of four different types. It can make checks during the data communication. So that is what VRC, vertical, LRC, CRC and checksum. So what is vertical redundancy check? Vertical redundancy check, when the data is transmitted, it even parity generator is being present here, which will be adding up an vertical redundancy checksum. That is, one is an extra bit that is being added and which is used for checking out whether the ones are even or not at the receiver side. So the performance of this is to detect single bit error, and it can detect burst errors only if the total number of errors is odd. If it is an even number, means it is not possible to detect it by using this vertical. Logical redundancy check is longitudinal redundancy check is nothing but this is how the direction of movement it will happen, and here it will add up an extra set of 8 bits at the end, at the beginning of the data. Okay, so this 8 bits is being transmitted along with the data. Increases the detecting burst errors. It mainly used for detecting burst errors. If two bits in one data units are damaged, or two bits in exactly the same position as in another data is being damaged, it is mainly used for checking out this. So VRC and LRC, here LRC is for a bulk set of data transmission, whereas VRC can able to check only for one bit. Okay, so when you see about the cyclic redundancy check, it just goes for n number of checks. Okay, till then there is no zero or accept non-zero or rejected process happening. It just goes for checking out repeatedly. That is what we call it as cyclic redundancy check. So k bit frames or messages will be present, and the frame check sequence will be present here, which will be checking out simultaneously with the concept of dividing the frames, incoming frames by the same number, and if there is no reminder, assumes that there is no error. So this is what cyclic redundancy check happens. So there is a binary division shown with an example here. So a divisor and a quotient is present, and a division is happening here, and here the reminder which is having 0 doesn't have any error. If it is being holded up within 1 bit, it denotes that there is an error in this. Okay. Next is about polynomial. So polynomial is nothing but the representation of data. For example, it is given like this. So here the polynomial error is nothing but 1, then comes x square, x cube, and x to the power of 4 is missing out. So it's being represented as 0, 0. So whereas x6 is missing here, it is being represented as 0. So this is how the polynomial and the divisor is being calculated with the help of a polynomial value. So the standard polynomials are CRC, that is cyclic redundancy check, which will use dividend and the divisor for the process. It just goes along with the CRC checks. The final type of error reduction is the checksum. So this checksum, the process is being represented here in the form of a block. So your data is being transmitted in the form of n bits. Those n bits will be taken up in the form of sections here, and each section will be checked up with the sum, and the checksum will be of n bits. So the complement will be taken up to check whether there is an error into it. Okay, so checksum detects all the errors involving odd numbers of bits. It detects most errors involving even number of bits also. If one or more bits of segments are damaged, or corresponding bits or bits of opposite values in the second segment is also damaged, it can be clearly identified with the problem what is happening and which of the bit that is being transmitted with the help of checksum. So here comes the different forms of error reduction methods, and they can help the data transmission to make in a secured manner. Thanks for watching this video.